This video will deal with the concept of electroplating, and in particular looking at the processes involving in electroplating a spoon of silver. Now, electroplating is an application of electrolysis. It's got a number of interesting applications. One relates to the coins that we use as money. The coins that we would use are 5 cents, 20 cents, 50 cents, 1 rand, 2 rand, etc. They start off as zinc discs, and then through a process of electrolysis and electroplating, they are plated, often with copper, and they then have the particular image that we're used to seeing. Gold-plated jewelry is another example of an application of electroplating. But we're going to be looking particularly at electroplating a spoon, and we're going to choose silver as an example. So you can see we've got the setup here. We've got a battery. The long end on the left is the positive, the negative end on the right. The positive end of the battery is attached to a silver strip of silver metal, and because it's attached to the positive end of the battery, it would take on a positive charge. And then we have a spoon. It will probably be an iron spoon that we are wanting to plate with silver. That's connected to the negative end, and so the spoon would be negatively charged. And the spoon and the silver strip are then immersed in a solution of silver nitrate. So the strip of silver that's positively charged constitutes the anode. The spoon, which is negatively charged, constitutes the cathode. The electrolyte is silver nitrate, and that electrolyte would contain silver ions. You can see those illustrated in the solution, and would contain nitrate ions as the anion. Those are just spectator ions in this particular electrolysis process. So let's consider what happens at the anode, the strip of silver metal. Because it's positively charged, the silver atoms that constitute the strip of silver go into solution as positive silver cations, positive silver ions, and release an electron. And so that half reaction Ag to Ag plus an electron, you can see the silver atoms are losing an electron. So that's an oxidation reaction. And you remember that the mnemonic oil, oxidation is loss. We've had an A in the end, oila, and that A reminds us that oxidation is loss of electrons, and it happens at the anode. So the strip of silver metal is defined as the anode because that's where oxidation takes place. Now, having a look at the spoon then, it's negatively charged, so the positive silver ions in solution are attracted to the spoon, because they're positive and the spoon's negative. At the spoon, the silver ions gain an electron to form silver atoms, and those atoms of silver then slowly start to coat the spoon. Here we have the gain of an electron, so that's obviously a reduction reaction, and those happen at the cathode. So what's the net reaction taking place then? We've got an anode half reaction, we've got a cathode half reaction, and if you add those together, you get a very simple reaction, silver metal plus silver ions giving you silver metal and silver ions. So there isn't a change in the species, but there is a very important change in where the silver in particular is positioned. So the reactant is silver from the silver strip, and the product, the result of this electrolysis reaction, is silver that's now deposited on the spoon. And so as this electrolysis cell runs, the silver strip will slowly corrode away, and the spoon will be evenly plated with silver, and we'd end up with a silver-plated spoon. Let's have a look at this example quickly. Here we have a setup where we're going to coat an iron nail with copper, and so the negative electrode is connected to the iron nail, and the positive electrode to the copper rod. And so the copper rod there is positive, the iron nail is negative. So at the positive copper rod, copper atoms will go into solution as copper ions. Those positive ions then would be attracted across to the negative ion nail, and they would be deposited there as copper. And so if you look at the half reaction, the copper 2 plus ions that are in solution would gain 2 electrons. That would be reduction, and so the ion nail there is our cathode, and it would slowly be coated with copper. If you look at the diagram on the right, after some hours of running this electrolytic cell, you'd see that that ion nail is coated in copper, and you'll see that the original copper rod has been corroded away as the copper atoms from that rod have gone into solution as copper ions.